Hi everyone, just wanted to do a video sharing my experience with swapping logic board on a Prius inverter with this logic board that's provided by EVBMW, so that's Damien, Maguire, and Johannes have been working on that. So anyway, just wanted to share my experience in doing this swap and soldering all the bits and pieces onto the board. So I guess first things first is I bought this Toyota Prius inverter off of eBay. I think I ended up paying about $165 shipped to my door. So best I can understand and what I've read is that this particular inverter is for a 2012 Prius. So it's 3rd gen. And one of the things that's important, you'll see a little bit later, is that the number here is a 9200 47210. So this is a 2012 inverter, not a 2010, 2011. So I've already got this thing busted open, and just one of the things that I did to get it open was basically use this putty knife to slide along the edge here, just being careful not to get too far into the inverter to mess something up or cut wires or whatever. So I've already been in this inverter, so I've taken the current sensors off, so I'll just pop them off here. So like this, MG1 current sensor, temperature sensor. Now I can remove this current sensor assembly. I'll set that off to the side. And so here is the logic board out of this particular inverter. So if you compare it to one of the issues that I ran into was that the logic board that that's produced by EVBMW, and the design there is, I believe this is for a 2010, 2011 Prius inverter, because what you see is that for the 2012 inverter that I have, the logic board is a good bit smaller. So I measured this logic board out of the 2012 inverter, and it's 150 millimeters by 143 millimeters. So the designation on this particular board is F1759-47070 and 05. So I think that from looking at the forum, I think that they may be using this board maybe in a Yaris and RS. So anyway, that posed a challenge because the bolt patterns and pins here are different than they are for Damien's board. So that's something that I had to address. So the route that I took was to take Damien's zip files that he provided on GitHub, and basically all that I did was upload them to JLCPCB, and they assembled and produced all the components in the board that you see here. So took them about 10 days, I believe, from time of upload to arriving at my doorstep. The other thing is that this 50-way connector here I bought from Chip One Stop. So let's see here. Yeah, here we go. So yeah, this is all part of the, all in the bill of materials that's in the zip file for the logic board that Damien provides. So yeah, just went to Chip One Stop and got this 50-way connector here. So what I ended up getting was 5 of these boards. I think I ended up paying about $190 for the logic boards, and also the boards for the amp seal 35-way connector. Let's see here. So I also bought all the pieces on the bill of materials, all the extra pieces that I needed to assemble the board. One note that I will make is that this L2 inductor, JLCPCB, did have that in stock whenever I ordered these boards, so that was automatically, JLCPCB installed this component. It's a little bit different than part one of Damien's tutorial. The other thing that I did was, because I bought these from JLCPCB, the two MCUs here, the Atmega 328 and the ARM chip for the running the controller are blank. So I did upload Johannes's bootloader and then also the sine inverter software onto this ARM chip. The Atmega 328 I just left blank. This Olimex ESP-8266 Wi-Fi chip, I uploaded Johannes's software onto this. I'll probably do a separate video about that. But yeah, so this is the assembled board with the hand soldered components on it. So I did all that. Let's see here. Let's see. So speaking of soldering components, what I'm using to do all this is this Weller WES-51. So that's the soldering tool that I'm using. I don't have any special soldering tips or, I'm not any more proficient at that than anyone else. So I have rudimentary through-hole type experience with soldering. One of the things that I did do is get this very fine tip for my soldering iron, and that's just so that I can get into these places on these surface mounted devices, especially with this 50-way connector. So back to the issue of the board being a different size. What I ended up doing was it had this space here where there weren't any components on the board. So what I ended up doing was just drilling another set of holes just through the board, just so that I could make this board that Damien designed work with this 2012 inverter. One of the things that I did try to do here was I just added a piece of wire to this mounting hole, just so that I could connect to this copper strip that's grounded to the case. So I suspect that in the design here that this is meant to connect the ground plane of the board to the inverter, but I don't know that for certain, but that's just how I address that issue. So I think what I'm going to do is probably, I wasn't able to drill the hole, the fourth hole for mounting this board from Damien, because it is under this connector. So I think what I'm going to do is just end up bolting it down here, and then maybe I'll just put a glob of hot glue under there, or maybe just forego the other screw and just see what happens. Yeah, so that's that. I guess one other thing about this board is that if you look in the 2012 inverter, if you look, it's oriented like this. What you see is that the connector for MG2, the current sensor for MG2, and you have this temperature connector here. So you have, in the 2012 inverter, you have temperature here and current sensor for MG2 connector here. But in Damien's design, it's a little bit different. you can see that the temperature connector is down here, and then the current sensor connector for MG2 is up here. So I've test fitted that, and none of that's a problem. The wiring still fits, the connectors still connect, and it's all good there. So I think what I'm going to do is just mount this board, and then I'm going to solder this piece of wire that I've added. Just solder that to this copper strip that's on the inverter here. So and so there it is in the inverter. One of the things that I had to do was there is a slot here for letting some wiring come up for the current sensors. So because I think the issue here is that the board support, this white piece, is smaller for this 2012 inverter, and I think for the 2010 and 2011 inverters it's a bit wider. So what that meant was that I had to do a little bit of trimming, just use some wire cutters and trimmed around this notch, just so that this board would lay down flat and it would fit around this this slot here. So that's kind of where I am. I'm gonna solder this wire here, bolt it down, connect everything up, and then I think I'll be off to the races. So I think that's going to be it for this time, and I'll probably make another video and just share with everybody the next steps.